a variable RL. That case we already done yesterday. So what we do here, if we have a source whose VI is fixed, series resistance RS was fixed. Here was Zener diode, for which we know the VZ and we know the performance parameter IZ max we know, and here RL was variable. This RL was variable. Okay, so we found, okay, we can find this RL. This RL can vary from RL minimum to RL max. Okay, and in order to find the RL minimum, what we have done, we told that voltage across V load. Okay, we open or we say V across RL, V across RL, V across RL, or we say V load, we will put equals to VZ. Okay, and now we know the V load or V load is equal to VI upon RS plus RL minimum. Okay, for minimum value, RL minimum, okay, is equal to V into RL minimum equals to VZ, and from this equation I can find the value of RL minimum. Okay, similarly we have seen the RL max. RL max, how can I find out? So obviously RL max, so when your VI is fixed, so if here IZ max is flowing, here IZ minimum will flow. Yes or no? How to find out? Tell me. So if I want to find my, if this is conducting, so this voltage is fixed. So IZ is fixed. So if suppose a I current is flowing, so this I RL max, how can I find? I can find my I will be equal to IZ max
plus IL min.
plus IL minimum. Okay. And IL minimum, because IL minimum will be what? This is IZ max will be given. And IL minimum will be, tell me, VZ or VZ or VL. We say VZ upon how much? RL max. Okay. From this equation, you can find you'll be knowing this one. You'll be knowing this one. Now you want to find I here, and I, how can you find? Tell me. I is equal to, tell me, this you know, VI minus VZ upon RS. So if you know I, you know IZ max, you can find the RL max by this equation. Okay, so now the things are different. Now the second case we'll discuss. Okay, I'm erasing this one. You write the formulas and
Yes,
you can.
sir.
So let us discuss the second case. Case number second says that if you want to find your VI is variable, VI is variable, and RL is fixed. RL is fixed. RL is fixed. Okay, that means now we have a source. Okay, V input, which varies from V minimum to V max, and here you have a RS. Here you have a Zener diode, and here this RL is fixed. Now, if V minimum, what V minimum should see? Now, if I want minimum value of V, that we already know. If I want to make this operate, there should be something minimum value of this one for given RL fixed. That case we have already done. So we say that V minimum will be what? Vi minimum. Okay, for Vi minimum, what I should do here, I should open side voltage should be equal to the Vz. So V open should be equal to Vz. Okay, and V open is what? Vi. Now this is minimum. So minimum value V minimum, and this is Rs plus RL into RL. This will be the minimum value of this one. I can find what is the minimum value by this equation. Okay, and now the how to find the max value. Okay, tell me how can I find the max value? So Vi minimum I can write from here. It will be Rs plus RL upon RL equals to Vz. And so Vz is given, Iz max is given. Now, if you apply this minimum, this will start conducting. Now you increase you are increasing your V input. So this is conducting state. Once this is conducting state, here IL is fixed. Here now IL is fixed. Because this load is fixed, this voltage is fixed, IL is fixed. Okay. And now if I increase the voltage, what will happen? This voltage will not change, this current will not change. So only apply voltage, increasing voltage. Okay, here voltage is fixed. So this voltage will change. This voltage increasing because this voltage is equal to this voltage and this voltage. When this is fixed, further increasing this one, only this voltage will increase. Now this voltage increase means current will increase. And when current will increase, that means this current is fixed. This current will increase. So this current I can go up to Iz max. Okay. So my Vi max will be what? My Vi maximum will be what I can do. This will be equal to this plus this. So this will be IR. How much IR max I can go? IR max into RS plus Vz. I cannot go beyond some particular value IR max because when increasing, this is fixed. So this is increasing. So now what is IR max? So IR max is equal to your Iz max plus IL. Now here IL is fixed when fixed because load is fixed. So by this equation, you can find this one. This will be given. This you can calculate. Vz will be given, and by solving this one, you can find V minimum and V max. If you have any doubt, please ask me. I will clarify again. If you don't understand what is V minimum is the voltage for which will make it diode conducting. Okay. So at least here I want the voltage should be Vz. From there, I can find the V minimum value and V max because this is once is more than minimum, it is fixed. Now, if I increasing this one, this voltage will increase. That means this current will increase. This current will increase means this current plus this current is fixed. So this current will increase. So I can go up to IR max. IR max will be Iz max plus IL fixed. So by using this formula, we can find the value of V max, Vi max. Okay. Let us understand with an example. हाँ बोलिए.
Sir, can you explain once again how to find VI max? Sir?
Vi max. Vi max or Vi
Yes,
minimum?
Sir. Yes, sir. Yes, max. Sir.
See, max. See, first you have to apply voltage. We have to find V minimum. Once you know the V minimum, suppose this is 10, this is 15 volt. Now, if I go to 16 volt, what will happen? This is Vz fixed. This I am changing, so voltage will change here. Yes or no? Yes or no?
Yes.
16. So suppose this is 10. This is 16. 6 is here. Now 17. 7 is here. Which here 10 is fixed. 18. Here how much become? 8, 19, here become 9, 20, here become 10. So voltage here keep on increasing. Okay, now voltage and keep on increasing, that means this IR max is keep on increasing, this RS is fixed, this RS max is keep on increasing. Now RS max maximum can be how much? RS max maximum can be IZ max, and this IR is IZ plus IL. Now IL is always fixed in this case. So increasing IR max, only IZ max is increasing, and this current is IZ is increasing. So IZ I can get up to IZ max. So once this value is fixed, up to this much current is reached, after that I cannot increase VI. I'm increasing VI. This V input is basically what? This V input is basically RSI, this one IRS, IRR plus VZ. Now if I'm increasing this one, this is increasing. If I go max, this is fixed, so only this is increasing, because IL can now this is increasing means only an IR is equal to what? IZ plus IL. When I'm increasing this one, this particular case, this cannot increase, so only this is increasing, so I can go up to maximum here. So if this is given, this I can find what is IR, from there I can find VI max. Is that clear?
Yes, sir, clear.
So let us understand with one example. I have, say, a value of V input is changing. RS value is, say, 220. RS value is 220 ohm. VZ is 20. This is 20 volt. VZ is given 20 volt. And IZ max is given 60 milliampere. IZ max is given 60 milliampere. Okay. And here you have some fixed value of RL, which is equal to 1.2 kilo ohm. Okay. Find V input minimum value and V input max value. Find out. So tell me, what is VI minimum? VI minimum will be, tell me, formula is what? RS plus RL upon,
23.6 volt.
and this is VZ. VZ is 20. Okay. So 220 plus 1.2, that is 1200 ohm. Okay. Plus RL is 1200 into 20. This become 1420 upon 1200 into 20. कितना आ रहा है?
23.6.
Yes, 23.67 volt is the value of V minimum. Okay. And now this conducting. If your value is greater than this one, They start conducting. Now Vi max will be how much? So first you have to find IR max. IR max is IZ max plus IL is now fixed. IZ max is 60 milliampere plus IL is how much? IL is here 20 upon 1200 ohm. How much? 16.67 milliampere. Tell me, is coming or not?
Yes, sir.
1 by 60, huh? 1000 by 60, correct. So 1000 means, so this is 16.67 milliampere. So my IR max becomes 16.67, that is 76.67 milliampere. This is my IR max. So Vi max will become IR max into R plus VZ. So that is 67.67 milliampere into 220 ohm plus 20. How much is coming? Tell me.
36.8.
Yes, 36.87. 36.87 volt. This is the correct answer. So this way, you can find case number 2 for fixed RL. Vi is varying. Then you can use this one. Okay. Now third case. Case number 3 we'll see in this circuit. Now case number 3. Case number 3 means I want to find a series resistance. Series resistance also can go from RS max to RS minimum. Okay. Now say you have a fixed Vi. Okay. You have no Vi is changing. Okay. So now say this is your source. Okay. And Vi is variable. Say this is minus. Vi is variable. Here RS value, which is variable. Here you have a Zener diode. Okay. And here RL is variable. RL goes from RL minimum to RL max. Okay. That means IL goes to IL max to IL minimum. Everything is varying. So in that case, if this is varying, this is also varying. So we have to adjust this one. Okay, why to adjust this one? Now suppose if I changing this one, suppose diode is conducting. And now if I increasing this voltage, so I told you if this is become fixed, okay, here current will become fixed, some load, some resistance. So here voltage fixed. Forget this one. If I'm increasing this one, here VZ. So here voltage will change. So here current will change, and current will go keep on current will keep on increasing. Okay. Suppose I'm now up. Now I am at VI max. I am here up to VI max. So once this is VI max, this is IR max. Here current is IZ max. Okay. Here current is IZ max. So here this is IR max, and here the current is IZ max. Now if I decrease this one RS value, then what will happen? Tell me. Tell me. If I'm increasing this VI max here, okay, so
More
value.
more will be the potential.
No. I am decreasing R. So current will increase or current will decrease?
It will increase.
Current will increase. So this current will also increase.
Yes, sir.
So this will burn. Okay. That means here also some limit is there. So here
Yes, sir.
here also some limit is there. So here I have given two batteries, which can go from VI minimum to VI max. Okay. So when I apply VI max, I am getting some current here, some current here, some current here. Okay. Forget this idea. I have some two batteries here. He says the battery range is from this to this. Now I'm applying VI max. This is my maximum range. Okay. And now this is conducting. Now if I'm keep on decreasing R, my current will keep on increasing, and this current will keep on increasing. And there is a minimum, minimum value of R, okay, for which this become greater than IZ max. So I want to find the RS minimum. So RS minimum will be what? VI max minus VZ upon I. Okay. I. And I is what? I is this IR. IR is equal to VI max minus VZ, and this is equal to IZ max plus IL minimum. This value, okay. What does this mean? Here I am taking here minimum value of RL. No, I am taking the maximum value of RL. So when I'm taking the maximum value of RL, the fraction of this current mostly going from here. Okay. So here RL is max, so IL is minimum. Now I'm applying some voltage which is sufficient to make it conduct. Now I'm keep on increasing the voltage, Okay. Now this, because here RL max is there, here current become fixed, IL minimum. Now I'm keep on reducing this one. So my IR keep on increasing, a particular value here, I become IZ max. So I will stop here. This is my RS minimum value. Okay, this is the formula for RS minimum. Tell me it is clear or not? Or shall I explain again?
So एक बार दोबारा कर दीजिए इसको.
So suppose I have a batteries here, V minimum to VI max. Now I say my VI and diode is conducting. Diode is conducting means now VI, VI minimum means I have a range of battery. I have range is given, and these both the ranges are sufficient to make it conduct. Okay. Now I'm applying VI max, and with VI max this is conducting. Very good. Is conducting. Now see, this is conducting. So some voltage is here, here. Now I can change this one and this one. Okay. Now what I'm putting here, I am putting RL max here. So here only IL minimum will flow. Okay. Now this is also become fixed. This voltage is fixed. I have changed the resistance which is available with me. Here also range will be given. So I have taken this IL minimum. Now if I change this voltage for a certain value, this voltage will keep on increasing. This voltage is fixed. Now in this way keep on moving. I go to up to VI max. Now I'm applying VI max here. So here some voltage is the fixed voltage. Here voltage is fixed. Now I'm reducing this RS, and I'm telling RS cannot go beyond this value. I have some batteries. Say I have a range is given 10, say 20 volt to 30 volt range is given. So I choose the maximum value of this one and say here this is 10 volt. So remaining 20 is coming here. This is 30, 10 is here, 20 is coming here. Now what I'm doing, now 20 is coming here. I have put it here RL max. So IL minimum is going here. Now here this I depends on only this RS. If I keep on decreasing R, this I will keep on increasing. This become fixed now because resistance is fixed. So only IZ is increasing. So I can reduce R such that my IZ should not go beyond IZ max. Maximum I can go up to here. So this type of case is called worst case condition. It's called worst case condition. Worst case condition means you are taking the max here and minimum current here, maximum voltage here and minimum current here. So I'm taking VI max here and RL I'm choosing for IL minimum, that is I'm choosing RL max. So maximum, minimum, minimum, maximum. So this is my RS minimum value. Now if I want to find say RS max value, what is the value of RS max? Now worst case condition is there. I am putting here VI minimum. Okay, which is just greater than to make this conduct. Okay. Now if I increase RS, what will become? Say I given you the range, this is a 20 to 30. Now say I'm applying 20. Here voltage 20 and this is conducting 10. Remaining 10 is coming here. If I increase RS, what will become? I will decrease or increase?
It will decrease.
I will decrease. So I will decrease. So IZ will also decrease. Yes or no?
Yes, sir.
Because I am putting here max here minimum, here max. So here current become fixed now. Okay. And now here what is happening? If I'm increasing R, my IZ is increasing. And IZ should not go beyond less than IZ minimum. Otherwise, this will become not conducting. It will become open. So now I can find the value of RS max. So this I'll take minimum. I'll take VI minimum minus VZ and here IR. And IR now here I will take minimum minus VZ. IR I will take here IZ minimum plus IL max. This will be given in the question. IL range will be given. So by using these two formula, you can find the value of RS minimum and RS max. Okay. If this is also varying, this may be fixed, this may be fixed, this may be varying, but this is varying. Okay. So if you want minimum, you take VI max. If you want to max, you take VI minimum value. So this is the worst case condition. So let us understand with some example. Some questions we will apply this one. Tell me if this point is clear to you or not.
Yes, sir.
Is there any student who's not getting Leo?
सर
हाँ बोलो.
Clear, sir.
सर यहाँ पे लास्ट जो एक्सप्रेशन हुआ है वहाँ पे डिनोमिनेटर में आईजेड मीन प्लस आईएल मैक्स है.
हाँ.
तो यहाँ पे आईएल मैक्स जो है आरएल को मैक्सिमम वैल्यू लिया गया है या मिनिमम वैल्यू लिया
RL
गया
को
है?
मिनिमम वैल्यू लिया गया है.
ओके ओके डन.
Okay, तो वही यहाँ पे here if it is maximum, here RL is max. If here is VI minimum, RL minimum. So IL become max. Okay, so here maximum, current minimum. Here minimum, current maximum. This is the worst case. Okay, keeping
sir.
these
Okay.
all criteria is this is limitations. You have to find the value of RS. Okay, in the circuit. So this is called worst case condition. Now let us understand with this some formula. So this problem came in your exam. Here, this is varying from 15 to 20. Here is RS. This is 6.8 volt. Okay. And here I load is varying from 5 milliampere to 20 milliampere. Okay. Find the value of RS max. So find the value of RS. Now this is a what the value of RX you can find. If this is the condition, IZ max is not given. If IZ max is not given, then you cannot calculate the RS minimum. So in this case, only you can find the value of RS max. Okay, find RS max. Find RS max. Tell me what is the value? RS max.
So here we how we can calculate the value of IL min,
That we have to
IZ
see.
min,
Yes,
IZ
very good.
min.
Yes, very good. That is the question. Okay. So options are given. A, B, C, D options are given. And the option says the value of RS max is equal to 390 ohm, 420 ohm, 440 ohm, and 460 ohm. Okay. Now, if you want RS max, you can immediately put the formula RS max is because the max. So what will take here minimum VI minimum. I will take VZ. Okay. And when I take VI minimum, obviously my current is IZ minimum, and I will take IL max. Okay. Now IL max is given in the question. VI minimum is given. BZ is given 6.8 volt. IZ minimum is not given. Okay. If I reduce IZ minimum, if I put IZ minimum 0, then the value of RS max will go high or low. If I put this one 0,
It will be lower as IL is already maximum.
this value is fixed, this is fixed, this is fixed, this is fixed. This you know 20, VZ you know, VI also you know, minus 15. Now if this value I don't know, suppose this value is 1 milliampere. If I put it 0 milliampere, this RS maximum value go up or go down? It will go up, na?
Increases.
Increases,
Increase.
increases, na? So now if by putting this one, whatever RS I will get, my value should be, actual value should be less than that value. Correct? Leo, if I put, suppose this is a 5 milliampere, but I don't know whether 5, 3, I don't know. So if I put 0 this one, this RS max will go up. Okay, because I'm putting 0. That means my actual value will be the less than this value. This will be upper limit. Okay, so if IZ minimum is not given, you put it 0 here, and now you find out RS max. Okay, and your value will be less than this value. Okay, your actual value will be less than this value. So VI minimum is how much? VI minimum is 15, and VZ is 6.8, and IZ when we put 0, IL max is 20 milliampere. Tell me how much is coming this one? RS max. What is the value?
410.
410 ohm. Very good. But this is the upper limit. My value should be less than this one. So which is the option? Correct option?
390.
390 is the correct option. So either this value will be given, so you can accurately find out. If this value is not given, then this is case. You put 0 and you can find this one. But if you want RS minimum, that time you should know what is RS this IZ max. Okay, that time you can put IL minimum 0. We'll see that in questions also. So let me do one more problem. say only you have to remember the formula. This is 30 volt. This is your RS. This is xenon diode. You have this is 12 volt. And this is your 140 ohm to 10 kilo ohm. Okay. Find RS max. Find the RS max value. Find out RS max. Again, IZ minimum is not given, so you can put it 0. So less than that one will be. So now what I can find? I can find now VRS max is equal to VI minimum minus VZ upon IZ minimum plus IL max. Okay. So I'll take IZ minimum 0 is not given. So I can write VI minimum minus VZ. I want to find IL max. And IL max will be what? IL max will be IL is first IL is what? IL is your VL upon RL, and VL is equal to VZ upon RL. If you want IL max, that will be VZ upon RL minimum. Okay, so VI minimum minus VZ, and it's the VZ into RL minimum. Okay, put the values. You have minimum value is 22 minus 12, 12 minus 12, 12 into RL minimum value is 140 ohm. Tell me what is the answer?
Hundred and 16.61.
Yes, 116.67. 116.67 volt is the value. Okay. Let us do some more problems. So only you have to remember this formula. If you don't understand this formula, you can put the values by varying values and you can find. Okay, that's it. If you're not clearing the concept, you just remember the formula. Okay, we'll do some problems now. Say I have a 30 volt battery is given. A 500 kilo ohm resistance is there. A xenon diode is given. And here a 10 volt xenon diode is given. This is 20 volt xenon diode. This is 1 kilo ohm. And this is a 2 kilo ohm resistor. He asking what is the value of IL. Okay, what is the value of IL in the question they're asking? What is the value of IL and VL? That you need to calculate. Your Zener diode 1 or Zener 2. Okay, Zener, JD. Zener diode 1 and Zener diode 2. Tell me how to find, how to solve this kind of problem. So if these two Zener diodes are, if both are on, okay, then what is the value here? Tell me. What is the VL? What is the value of VL? If this is on, what is the value of VL? Subhashish.
Sir, let me guess.
गैस थोड़ी करना अभी, ये ऑन हो गया, इफ इट्स ऑन है तो यहाँ वोल्टेज कितना हो जाएगा? व्हाट इज द वोल्टेज हियर इफ दिस इज if this is on?
It's a 10 volt.
10 volt. So what is VL?
10 volt.
10 volt. Okay, and now 10 volt divided by 2 kilo ohm, you can find the IL. Okay, but whether this is on or off, how do you know? Okay, that we have to check.
Sir, what about a 20 volt?
That's what I'm asking. See, if you know this on, this is on, is on. If you know this is on, you can immediately say I know the VL, I know the IL. Okay, but I don't know whether this is on or not on, or I also don't know about this one also, whether this is on or this is off. Okay, so first of all thing, I have 4 cases. 4 cases means both are open. Okay, the case number 1, both, I'm saying not D1, both D1 and D2 are open, but not conducting. Second case I have D1 is on and D2 is off. Okay, both D1 D2 are off. First case I'll take. Off means open. Now second case is D1 is on, D2 is off. Third case is what? Third case possibility is D1 is off and D2 is on. And the last case is both D1 and D2 are on. So now I have to find out first what is actually is happening. What is the actual state of these Zener diodes? Okay. So first of all, I am assuming both are off. I'm checking this one. Okay, I will take first case. Both are off. If both are off, then I can remove this one here. I can make it open, and I can make it open. Okay, and now I can find out what is the voltage here. Okay, say V1 and find a voltage V2 here. Tell me now what is V1 and V2. What is the voltage here? And what is the voltage here at this point? So you find total voltage is 30. You can find the current flowing in the circuit. Total voltage is 30. Resistor is how much? 1 kilo ohm, 3 kilo ohm, and this should be 500 ohm, not kilo ohm. It should be 500 ohm. It should be 500 ohm. Okay. So now you have how much? 30 volt, 1, 2, 3, and 3.5 kilo ohm. 3.5 kilo ohm total. Okay, now you know the current. Now you can find out how much drop is here. So drop across 5 ohm, 500 ohm. Okay, basically V1 is what? This V1 is what? This 30 minus drop across 500 ohm. So 30 current is, so your resistance is your 500 ohm. And the current is this one, 30 upon 3.5 to 10 raised to power 3. What is the voltage? Tell me. What is V1? -30 minus
Sir, it's
1.
25.7.
Very good. 20. So this will be something. 35 means how much time it will go? 4 point something, na? 25 point. Tell me.
25.7.
Very good. So this is greater than 20 or not? This is greater than 20. So I require here 20 volts, so that should become on. But I am saying now this is off. So this cannot be true. This first case cannot be true because this value is coming 25.7, which is making this diode on. So this diode is on. So that means this case is wrong. And now if you find the voltage V2 also, that will also come more than more than 10 volt. Here I require 10 volt. So this value will also come more than 10 volts. So when I'm assuming both D1 and D2 off, it's coming both are on. Okay. Now I'll take the second case. Is that point to clear to everyone? When I'm considering both are on, my voltage here is coming greater than what I required to make it on. That my assumption is wrong. Okay. Second case, I say my D1 is on, D2 is off. So I say this is on. So once this become on, this become 20 volt battery. This become 20 volt battery. Okay. And I'm saying this is off. And now again, I'm finding this value of this V here. Say second case, V2 dash. Tell me what is V2 dash value now. Now I'm saying second case, D1 is on. So on means this is on. Now it is when this voltage become 20 volt fix. Now this 20 volt will go here and here across 3 kilo ohm. Again, some current will come. So this 20 volt will divide here and here. I want to find what is here voltage, the V2 dash. So V2 dash will be what? So V2 dash will be basically 20. This 20 volt will divide here. This is 1 kilo ohm plus 3 kilo ohm across 2 kilo ohm. Okay. So this is coming 40 by 3. It is again greater than 10 volt. So I am assuming this is on, this is off, but again this value is coming greater than 10 volt. So this case is also wrong. Okay. A third case I'm taking, I'm saying this is on. This is on and this is off. And now this voltage become 10 volt. So remaining 30 minus 10, this voltage 20 is coming here. If 20 is coming here, I can find what is across 1 kilo ohm. So across 1 kilo ohm, I will say now this V1 dash, some value. V1 dash will be 20 volt divided between 2.5 kilo ohm into 1 kilo ohm. So this is coming how much? Tell me. 1.5, not 2.5, 1.5. 1.5. So 20, no, this is 500 ohm. This one, so this is 30, okay. And now 30 minus 10, that's 20 divided 20 volt divided by 1500 ohm, correct? Okay. And I want to find the voltage across after getting drop here. Whatever drop here, it will come here. So tell me how much is coming now, this one? What is voltage coming here? Or what is the voltage drop across here? 500 ohm. What is the voltage drop across 500 ohm? That is 0.5 kilo ohm. So I'm cancelling this one. This become 10. 10 divided by 1.5. That is 100 by 15. Okay, how much is coming? Tell me. 100 by 15. This comes 6.6 something. Okay, so out of 20, here the drop is only 6.67. Okay, that means here again the voltage is greater than 20 volt. Are you getting my point? See, this is 30, this is 10, 20 is getting drop here. So here some current is there. Now 20 I have to divide here and here. Okay. No, this is not like this. So here is coming 30. So here 30 is coming, 30 volt is coming. And this is 10, 30 minus 10, 20. And divided by this, I can find the current and I can find the volt. What is voltage drop here? And so voltage drop here is only 6.6. So still this VI is coming greater than 20. So my third case is also wrong. That means now only possibility is the fourth case, which we have already checked. It can be correct. So now both the diodes are on. Both the diodes are on means this is also on, this is also on. Okay. Now I can say this is 10 volt, this is 20 volt, and VL is equal to now 10 volt, and my IL is become 10 volt divided by 2 kilo ohm, that is 5 milliampere. This is the answer. Now, basically, what I'm trying to say here, you have to check. Okay, in this cases, this is simple. Question is simple. Assuming this on, but you have to check whether this assumption is correct or not. So you have to two diodes are there. You have total 4 cases. All the 4 cases you have to check one by one, and you then you have to decide. So you have to always calculate the open circuit voltages. When I make it both open, my voltage coming here greater than 20, here greater than 10. That means both are on. If I'm removing, if I'm removing and putting this one, both are on. So automatically you can say this is in the first case itself, you can say this is on, and you can directly calculate. Even no need to check this one. But I'm just saying, if some circuit is like that where you have to check whether D1 is on or D2 is on. Here both are on. If you plug it out both, and you find the open circuit voltage, if you are putting this one, yeah, that means it is working nicely. So you can judge and you can calculate like this. Okay. Tell me this is clear or not? Karishma, tell me. What I'm saying is clear? Or shall I repeat again?
सर एक बार सेकंड केस बता दीजिए.
D1 is on and D2 is off. So अगर D1 is on कर दिया, D2 off कर दिया, ये on कर दिया, ये off कर दिया, तो बताओ यहाँ पे ओपन सर्किट वोल्टेज कितना आएगा? ये 20 आ गया ना? ये 20 कहाँ डिवाइड होगा? इधर में और इधर में. तो अगर ये निकालना तो इधर वोल्टेज कितना आएगा बताओ? कितना आ रहा है? इस 20 को डिवाइड करना है यहाँ पर और यहाँ पर. 20 has to be divided between 3 kilo ohm, and now voltage across 2 kilo ohm is how much? 40 divided by 3, how much? कितना आएगा बताओ भाई? 13 point something. 13 point something.
Yes sir, 13 point something.
And this is greater than 10 volt.
Yes sir.
So this should be also on. If this is on, this should be also on. If this is on, this should be also on. You can check it. That means both are on. Both are on. So if you
Okay,
say
sir.
this is first, you can check only 2 cases. You put this is you check it this one. You say this is on, then you check it. This is on coming. You want to put this one. You put this one on. Check it. This is also on. So both can be simultaneously on only. Okay, then you put both the on. And if you're taking both the off, then you're finding the voltage coming more greater than what is required. So again, it is proving that both are on. So like this, you have to check. Say I'm giving you a 5 volt, and this is your 20 volt, and this is your 500 ohm resistor here. This is your Gina diode. Okay, and this is a 1 kilo ohm resistor. Okay, it says find the value of PL max to PL minimum across the load. What is the value of PL minimum and what is the value of PL minimum? I'm giving you the break of 5 minutes. Now this is 6:30. I'll come to 6:35. Okay. Take the break and solve this problem.
Value of RS is 500 ohm.
Yes, 500 ohm. Anyone got the answer? Okay, 1 minute is there still. So I have battery of 5 to 20 volt. 5 to 20 volt. Okay. And VZ I didn't give you. VZ value is 10 volt. Okay. VZ value is 10 volt. Now, of course, 5 volt will not be sufficient to make it draw. Okay. So I require some here V minimum. So tell me what is V minimum. So first of all, 5, if I'm applying 5 volt, this is open and I can find what is IL here. Okay. So IL will be how much? Tell me what is the IL? IL value will be 5 volt divided by 1.5 kilo ohm. Is that correct? And this IL value will be how much? This will be say
1/300.
1 upon 300. This is IL. And the V load will be how much here? So I want P load. So P load will be how much? P load will be IL into VL. Okay. Or IL square into RL. Okay. And this will be 1 upon 300 into 300 into 1 kilo ohm is 1000 ohm. Okay. So this two cancels out, 1 cancels out. So this is coming how much? Tell me. 1 by 90 watt. Correct है क्या? Is that correct?
Yes, sir, it's coming.
1 by 90 watt. Okay. Milliwatt or watt? Watt. Kilo ohm. So I put it here RL. So 1 by 90 watt. Okay. Now suppose if I make it 6, this current will increase. 7, this current will increase. 8, this current will increase. So this is the minimum value. This is the minimum value flowing in the diode for given 5 volt. So this is my PL minimum value. Okay. Now what is PL max? Now you go 5, 6, 7, 8, current will keep on increasing. After that, when this diode become on, this current will become fixed. So now suppose here 16 volt is the minimum voltage required. At that voltage, this will become on and it will be replaced by a 10 volt battery. And now whatever IL flow here, that will be IL max, because now IL cannot go beyond this one. Your voltage fixed become, so this current become fixed. So now what will my IL max? So IL max will be V load. V load is 10 volt divided by 1 kilo ohm. 1 kilo ohm, that is 1000. So this will be IL will be 1 by 100 ampere. Okay. And now PL max. PL mix will be VL. VL is my VL or IL square. IL max square. This is 1 upon 100 square into RL, that is 1000. Okay. What become now? This 2 cancel. This become 1 by 10. Okay. Now I want the ratio of PL max to PL minimum. That is, I have 1 by 10 and upon 1 by 90. So the ratio become 9. PL max to PL minimum ratio become 9. This is the answer. Is that question is clear to everyone? नहीं हो तो बताओ. Saravati?
Yes, sir, I have understood.
Okay. So initially I am putting 5. I am finding some current. Now, if I go to 6, 7, 8, my current will keep on increasing. And for particular value, some value, this diode will become on. And after that, if I even though I keep on increasing, this voltage will not increase. So here current will become fixed. That will be the maximum current. I will find out the maximum current. 10 divided by 1 kilo ohm. I find the PL max, PL minimum. The ratio you found, the ratio is a 9. Okay. Now we'll see some different type of application of Zener diodes. Say I have, this is 12 sine omega t. This is your Zener diode here. And this is your value, some resistance R is there here. Okay. And this is your V across resistance. This is the V load. Okay. And now I want to plot the output curve. Input curve is given to me. This is V input is given as a 12 sine omega t. And this is 6 volt. Now I want to measure what is my VR. Tell me how to approach this problem. Is omega t, omega t. So my V input is 0. That means what is the current here? If V input is 0, what is the VR?
So 0.
0.
Uh,
So if my V input is say, so if I want to make this diode on, okay, my V input should be greater than 6 volt, yes or no? Because this voltage is coming here, here and
Yes.
here. If I want current to flow, first I have to make this conduct. Okay, so my voltage should be at least 6 volt. When my value is greater than 6 volt, then only this diode will become on. So until here, my current will be 0. Until I don't reach the 6 volt, my current will become 0. My output becomes 0. Current is 0, output is 0. And similarly here, whenever it is less than 6 volt, my current is 0 here. Now if it go above 6 volt, then my VR will be what? My VR is basically, it can go maximum up to, so VR is V input minus 6 and V input is 12 sine omega t minus 6. The maximum value it can go up to 12 and this maximum, so VR can maximum go to 6 volt. So after up to 6 volt, there will be no current. Now slowly it becomes 7, 8, 9, 10. Current will start increasing. So 6 is here, remaining voltage will come here. This is the 7 volt, 6 here, 1 year, 8 volt, 6 here, 2 year. So it will go up to, when it is 12, it will go up to maximum 6 value. It will go up to maximum 6 volt here. And now this diode is ideal, is given. In the forward direction, diode is ideal. Forward direction, diode is ideal. So this is for reverse cycle. This is for positive cycle. For positive cycle. Zener diode is reverse bias. Now, when you take negative cycle, this negative cycle, then current will start flowing like this, and this diode become forward bias. And forward bias, it is an ordinary diode, then you can replace it by a battery. Now all the voltage will come here with opposite sign. I am measuring like this. That means this VR is equal to V sin omega t. If this is short, this is equal to like this is negative, this will come negative. This will come negative. So after that, this one, this voltage will appear as it is. This voltage will appear as it is again for next cycle. Initially it will be 0, and then it will come like this, and then it will be like this again. So this is your output characteristics. Tell me if you don't understand.
So for negative
सर
cycle,
फॉरवर्ड सर
हाँ,
फॉरवर्ड बायस का थोड़ा और एक बार बता दीजिए.
हाँ. So in when is positive, this is a reverse bias. So whatever voltage come here, that is this minus 6. So this minus 6 is this one. If this is 6, this is 0, this is 7, this is 1, this is 12, this is the reverse bias. Now for negative cycle, okay, negative cycle, this diode is reverse bias or forward bias? For negative cycle, this diode is reverse bias or forward bias?
सर फॉरवर्ड बायस.
Forward bias, so I can replace it by ideal. I say forward action diode is ideal.
Ideal diode, right.
This short circuit, and once
Yes.
this short circuit, this voltage and this voltage is same. Okay. Now if I'm putting this one, this will come as it is here. This, because now I'm putting negative, na? So this
Okay,
and this
got
is same.
Got
So if it is
yeah.
positive already over, now negative, this is negative, so this is also negative. So it is same. This is equal to same thing. This is coming negative. और कोई इसको नहीं आ रहा समझ में? योशिता, is clear? शेखर,
Got it, sir.
करिश्मा,
yes, sir.
okay, let us do, if you understand this one, then we'll go to the next question. This problem came in your exam, okay? Now I'm taking some exam problems only. So let me do one more exam problem. Now you should able to tell me this very easy question, same. So you have, say, a value, a sine wave is given to you of amplitude 15 volt. Okay, V input is given 15 sine omega t. Okay, and now this is your circuit. Here some resistance is there. Here some Zener diode is there, and here some ordinary diode is there, and here you are applying your V input which is sine wave, and some R value is given. This is your 0.1 volt, and they say this is silicon diode. Silicon diode means 0.0. If it is forward bias, it should be 0.7 volt. It is given. Okay, and now you want to plot V load. You want to plot V load or V output. Okay, say this is V output. So I want to plot the V output now. I have a 15 volt V input. Tell me, for positive cycle, what should I assume? For positive cycle, what should I assume? And negative cycle, what should I assume? Tell me.
C not diode is positive.
So,
Reverse bias in positive.
so for positive cycle, for positive cycle, okay, this is 9.1 and this is how much? This is forward, this is a reverse bias, this is forward bias. So this requires 0.7 volt and this requires 9.1 volt. That means you require at least 9.8 volt. Yes or no? And here R is also not given. This is open, open. This is open. Now, if I want, if I want that this should conduct and this should conduct, this path should go. So I have to apply V input 9.1 volt and this is equal to 0.7 volt. So if it is open, what will be, if it is open, you'll get the voltage as it is, like this. Okay. Now if it's conducting, then the voltage here becomes 9.1 volt. So actually, what should you get the input? You should get the input. Now it says 9.1 plus 0.7, that is around 9.8 volt. That is around 10 volt. So up to here, before this one, say this is 9.8 volt. So before this one, this part will come as it is, and then this will become fixed. When this become greater than 9.8 volt, this will become fixed to 9.1 volt. So basically, your output should come like this, Then it should become fixed to 9.1 volt, and this should come like this. If it is open, this should come like this. But in the question, in the options, what they given in the example, they say because this part they are taking 0, so they are saying initially if no current is flowing in the load, if it is open, okay, then there is no current. If it is open, here also no current is there, so this is voltage, and here open, no current is flowing here. So they are taking 0. Actually, this is not 0. It should go as it is. But they are saying it is 0, and this is also 0. So this is for positive cycle. They are telling the answer is this one. Actually, this is not answer, but options, that is the best match answer is this one. So here, once this become on, you get 9.1 volt here, and here this part is negative. Okay. Now tell me what will happen in the negative cycle. If that you can click, you can tick the answer. What will be in negative cycle? Tell me. What will be in the negative cycle? Okay. Or you understood this question in a way. Suppose here I put a load resistance, say load, and I am measuring the V naught here. And this load is very high. RL is very, very high, very, very high compared to R. And this should be given in the question. Let me say a high impedance load network, high impedance is there. Load network is connected in the circuit. Okay. The forward drop voltage is 0.7. It's the same way with the input to 5 shown. Which of the following waveform quality describe the output voltage across the load? Okay. So this impedance is very high. This is not say resistor. This says impedance is very high. The impedance is very high. That means what will happen? If this is open, some current will flow here. Okay. So they are saying here impedance high means resistance current is low. What somehow they are saying this one. So this is saying this is 0 and this is 9.8 volt. Now in the reverse case, what will happen? You have to tell me what will happen. Reverse case. So reverse case, what will happen when you apply reverse case? This diode will become reverse bias, and this will become open from here. This will become open for here. Okay, now I will explain you again the full thing. What is the story? Say in the forward cycle, say voltage is less than this volt, so current will not come here, current will come here. But in order to current to come here, still you have to apply 0.7 volt. So initially you are expecting the current should be 0, and then it will increase, it should increase, but they are taking like 0 because this is you have to make it this diode also on. So initially current is 0, and when both are on, this is the voltage. This is the approximate answer. Question also they are saying what is the approximate correction. Approximate answer is correct. Now reverse bias, this will become open, so no current can pass here. That means for reverse cycle here again you will get 0 current, 0 output. This is the correct option. Tell me, shall I explain again or it is clear?
Sir, explain again.
So say here you have a diode. Okay. Now what is happening in the positive cycle? Positive cycle is coming. If the voltage is not sufficient to, if voltage is less than 9.8 volt, what will become? Current will come from here. But this also require some 0.7 volt. Okay. So if this requires 0.7 volt, so initially some voltage, this is also open, so there's no current flowing, so you get 0. When the voltage becomes greater than 9.8 volt, then this voltage will be your 9.8 volt fixed diode conducting. Okay, you get 9.8 volt. Again this coming down, you can assume the current is 0. You can make like this. Now reverse cycle, this part is plus, this is minus, which is making this diode reverse bias. So reverse bias, current cannot flow here. That means you cannot get V load. So for reverse bias, I am getting the output as 0, 0. Karishma, tell me what is the doubt. If until you don't ask the question doubt, how can I explain? Leo, tell me what is your doubt?
Sir, 9.8 volt is required, sir, during the positive cycle.
How much require?
9.8 volts, sir.
Yes, 9.8 volt requires.
Sir, in V output you have written 9.1 volt.
So once 9.8 become fixed, here voltage how much will come?
Okay, sir. 9.1.
9.1. Na? Here the 9 point will come. Load 9 point will come. Na? Yoshita,
Yes, sir.
clear?
Yes, sir.
Okay. So option also they say approximate. Okay, qualitatively. It's not actually what will happen. You require 0.7 here. So initially it will be 0.7. So it will be current, current open, and then when current start flowing, this is also open. Some voltage will come like this, and like this will come. This one. So this is this approximate, but they are putting like this qualitatively. So that is now problem in the options. Okay, that's why we're not able to do accurately. Now one very nice question is there. Now you can do it this very easily. You have a sine wave, V input equal to 5 sine pi t Here this is minus 3 volt. Now I'm taking V output here. So it says normal diode require 0.7 volt. This is a this is silicon diode, and this require 3 volt. Okay. So plot the output. Plot the output. So you have a sine wave of 5 sine omega t. Five, and you have to draw the V output. So tell me, if I am applying 5 sine omega t here, okay, which diode will be on first? Zener diode or normal diode? Which diode will become on first? Which branch require lesser voltage? Tell me. Which branch require lesser voltage to make it on? If I want to make this branch on, how much voltage is required? Karishma, tell me.
0.7.
0 point.
0.7.
If I want to make this branch on, how much voltage required? If I want to make this branch on, how much voltage required? Yes, Karishma, tell me what will happen.
Yes, sir, to make this open, we need 0.7 volt.
0.7 volt. Now, what about this 3 volt? If this become on, this is 0.7 volt. Total become how much? 3.7 volt. Okay. Because this diode is reversed by 3 volt. If I want to make this conduct, I need to apply at least 3.7 volt. And if you want to make this diode conduct, I require only 3 volt. So initially when the voltage is less than 3 volt, okay, this is also open, this is also open, no current is flowing, this voltage is coming as it is. So up to 3 volt, the input will be same like output will be same like input. And after that, this become on because this require only 3 volts and this branch require 3.7 volt. And I told you whenever diodes are in parallel, you have to see which branch require lesser voltage. So if this is 3 volt, this is on, but this cannot be on. And if this is 3.7 volt on, so obviously this is also on. But this 3 volt cannot be equal to 3.7 volt. So that means when there is 3 volt, this is open because this branch requires 3.7 volt. So the option this branch will be currently flow for this branch, and this will become fixed to 3 volt. And what will become in the negative cycle? Tell me. What will become the negative cycle? Negative cycle, it says, now what about the negative cycle? Tell me. So following circuit, choose the correct waveform corresponding to the output, V output, given this one, forward bias voltage of the diode. And now this says the forward bias voltage of Zener diode is also 0.7 volt. So for positive cycle, when I'm increasing slowly, this voltage is less than 3 volt. This is also off, this is also off. 3 volt, this become on. So once this become on, which is become first on, so this will remain the on. So this voltage become fixed to 3 volt. And when I'm taking a reverse bias, this diode become forward bias here, and this become forward bias. This voltage is become 0.7 volt. So in the reverse bias, what will happen? Until you don't apply 0.7, this will not become on, so it will come as it is, and after that it will become fixed to 0.7 volt here. So up to here it will come as it is, and then this become up to here, this become fixed, and then it will go down. So this is the curve, this is the correct curve for this output. Okay, tell me if you don't get. बताइए भी आ रहा है कि नहीं आ रहा है?
सर नेगेटिव साइकिल और एक बार बताइए।
साइकिल के लिए समझते हैं।
हाँ हाँ, नेगेटिव साइकिल में क्या होगा? Current is coming like this. This is already reverse bias. It is already reverse bias. Now you're putting like this, plus minus more. This is already reverse bias. So this branch is open. No issue. This branch cannot make conduct. Only now this diode become forward bias. Zener diode become forward bias. And this is also, this question says the forward voltage drop is 0.7. That means it is behaving like an ideal diode. Now, if this voltage coming in the reverse bias is less than 0.7, again, this is also open. So you get no current. So this voltage will come as it is. So this voltage is coming negative cycle as it is here. And after that, when this voltage in negative cycle goes beyond 0.7 volt increases, so this will start conducting, and this will become a battery of 0.7 volt like this. Opposite. That means V output is minus 0.7. This is minus 0.7, and this is a minus 0.7 volt. Come like this. Clear?
यस सर।
Yes, sir.
So if for forward cycle, this branch require lesser voltage, so this will become on. Okay. Reverse cycle, this is always open because it's a reverse bias. You're making more reverse because this is the minus, and this plus. Your diode is like this. It's already reverse bias, and now this minus coming more. This become more reverse bias, so this is become permanently open. Current can go here, and this branch requires 0.7 volt to conduct. So initially up to before 0.7, this will be like this, and this is 0.7, and then you can make it like this. Okay. So this problem came in IIT JAM 22. Okay. Now I'm giving you last question, today's last question. You have a resistance R. This is 125 ohm. Here you have a V input. This is 9 volt, and this is 65 milliampere IZ max is given, and the R value is here. RL value is 470 ohm, and this is your VL. Okay, it says find V input minimum and V input max value for this circuit. Value of V minimum and V value which will make this diode, or this keep this diode on in the circuit. Find the value and tell me the answer. So I'm not doing this question, it's a simple question. The formula already you know. You just calculate and tell me the values. You should able to perform the calculation very quickly ना, एग्जाम में तो टाइम इतना मिलता नहीं है, तो फास्ट करना पड़ेगा. VI minimum formula is what? R plus RL upon RL into VZ. RL is 1.25, 470 divided by 470 into 9. Okay. And when this is on, and I is I max, IR max, IR max is equal to IZ max plus IL. IL is how much? IL is 9 divided by 470. Okay. You can calculate this one. And VI max will be IR max into R plus BZ. Tell me the values. What is VI minimum? $125 plus 470, how much? 595 divided by 470 into 9. What is coming? Tell me.
So 11.3.
11.3, yes. So approximately 11.4 volt is the answer. Okay. Now find the IR max, which is equal to IZ max 65 milliampere plus this is 9 upon 470 ampere. Tell me now, put the value and put it here and tell me what is VI max.
$9.08 volt.
9 point, no. VZ itself is 9. So this is plus 9. This should be something around 10. 19 point something should count. This is how much milliampere, tell me. If I put 1000 here,
19.5.
19.5, yes. 19.5 volt will come. 19.5, yes. So I'll stop here. Okay, we'll continue tomorrow. Thank you.
Thank you, sir.
Mm.